Fusion energy by 2025. Can private companies deliver? The fusion revolution. Private investors declare energy's holy grail within reach by 2025, while scientists sound alarm on unrealistic promises. The essential takeaways. Several private enterprises have set nuclear fusion energy break-even targets for 2025, claiming a revolutionary advancement in clean energy production is imminent. Fusion energy generation involves combining hydrogen atoms at extraordinary temperatures, releasing vast energy without the dangerous waste products of conventional nuclear power. Companies including General Fusion and Helion are pioneering revolutionary approaches, but continue to face enormous technical obstacles and widespread doubt from traditional researchers. This high-stakes pursuit of fusion power could fundamentally transform global energy systems, raising crucial questions about whether private innovation and public research could compete or collaborate. The quest to harness nuclear fusion energy has reached a pivotal moment as privately funded companies boldly predict technological breakthroughs by 2025. These commercial ventures are attempting to convert nuclear fusion from a perpetually distant scientific dream into a practical, deployable source of emissions-free power. While corporate executives project confidence about reaching energy-positive fusion within months, many government-funded scientists who have dedicated careers to understanding fusion's complexities remain deeply unconvinced. As global attention intensifies on these efforts, observers question whether these aggressive timelines reflect genuine scientific progress or are primarily designed to satisfy impatient investors looking for returns. Fusion energy. Extraordinary potential meets extraordinary difficulty. The appeal of nuclear fusion lies in its extraordinary promise. Virtually unlimited clean energy production. Unlike traditional nuclear fission, which generates power by splitting atoms and creates long-lasting radioactive waste, fusion combines atomic nuclei and releases tremendous energy without hazardous byproducts. But here's where the challenge becomes monumental. Creating controlled fusion requires overcoming the natural repulsion between positively charged nuclei, necessitating conditions that mimic the sun's interior to maintain fusion reactions. To achieve fusion, scientists must heat hydrogen isotopes until they transform into plasma, where fusion becomes possible at temperatures approaching 100 million degrees Celsius, 180 million degrees Fahrenheit. Despite over 60 years of research and investment exceeding tens of billions of dollars, only the National Ignition Facility in California has demonstrated net energy gain by focusing immensely powerful lasers onto fusion fuel pellets. Other major initiatives, such as the International ITER project under construction in southern France, utilize tokamaks, donut-shaped chambers that use powerful magnets to contain plasma while heating it through microwaves and particle injection. However, ITER won't begin operations until well into the 2030s, highlighting the traditionally slow progression of government-sponsored fusion research. China ignites global controversy as CFR 1000 gigawatt fast neutron reactor triggers international alarm and creates deep divisions among nuclear experts about atomic energy's future. https:// Want to explore more about energy reporters and energy and its future, private enterprise ambitions, and breakthrough approaches as transforming clean energy, startups making renewable power a reality. The dream of cheap, clean renewable energy has long been a tantalizing mirage, but the tides are shifting. As we stand on the brink of a green energy revolution, the net zero economy is surging ahead. With over £40 billion of private investment in clean energy announced in the year to June. This isn't just a trend, it's a turning point. Sustainable Times will be celebrating the pioneers of this new wave in the 2025 RISE Awards. Among these trailblazers is Tokamak Energy, a fusion energy company that's bringing the energy of the stars to Earth. Based in Oxfordshire, Tokamak Energy is home to over 280 experts and has raised an impressive $335 million. Their compact spherical tokamak is not only more efficient, but also cheaper and safer to operate. The company's Tokamak Energy Magnetics division is pushing the boundaries of high-temperature superconducting, HTS magnets, a technology that could revolutionize industries beyond energy. With its small-scale design and low safety risk, fusion energy could provide clean power 24/7, making it a compelling alternative to renewables like wind. And it's not just about fusion. Hydrogen power is another exciting frontier, with companies like GeoPura leading the charge. Their hydrogen power units, manufactured in collaboration with Siemens Energy, offer a zero-emission alternative that can be used in industries ranging from construction to event management. But let's not forget the transport sector, which accounts for a significant portion of UK greenhouse gas emissions. Renewable is tackling this head-on with electric vehicle, EV fleet, and grid-scale battery storage solutions. From powering emission-free buses in Coventry to installing charging points in Oxford, Renewable is revolutionizing urban mobility. The road to a renewable future isn't without its challenges, but with a mix of solutions like hydrogen, fusion, and battery storage, we're closer than ever to achieving our net zero goals. The UK's ambitious target of net zero by 2050 is within reach, thanks to companies like these that are seizing growth opportunities and driving innovation. Are you a UK-based startup or scale-up working to solve critical sustainability challenges? Consider entering the 2025 Sustainable Times Rise Awards and join the ranks of changemakers reshaping our future. Physicists confirm forgotten 1938 fusion experiment, a breakthrough for clean energy. In a groundbreaking discovery, physicists at Los Alamos National Laboratory have replicated a long-forgotten experiment from 1938, which could revolutionize the way we generate energy. This experiment, once overshadowed by time, has now been revived and updated, confirming the potential of fusion between deuterium and tritium, DT fusion, as a viable source of clean energy. Fusion energy, the process that powers the sun, works by merging lighter atoms to release massive amounts of energy, unlike fission, which splits atoms. Fusion doesn't produce heat-trapping pollution, long-lived radioactive waste, or rely on scarce resources. If harnessed effectively, it could lead to lower electricity bills and energy independence for households and businesses worldwide. The revival of this experiment began when Los Alamos physicist Mark Chadwick stumbled upon a 1986 recording mentioning pre-war DT fusion experiments. This led to the rediscovery of physicist Arthur Rulich's paper from nearly a century ago, describing his experiments and observations on DT fusion. The physicists at Los Alamos decided to replicate Rulich's experiment at Duke University's Triangle University's nuclear laboratory. Their findings, published in Physical Review C, confirm secondary DT fusion reactions, proving that Rulich's claims, though imprecise by today's standards, were fundamentally correct. Chadwick stated, "Our replication leaves no doubt that Rulich was at least qualitatively correct when he said that DT fusion was exceedingly probable. This experiment was conducted at a much lower energy level than more complex, high-energy fusion experiments, making it a game-changer for smaller labs and opening the door to more accessible fusion experimentation. The implications of this discovery are significant for ongoing fusion studies. If scientists can successfully scale fusion energy, it could power entire cities more affordably than conventional power, while helping stabilize the grid. Fusion doesn't generate heat-trapping pollution, leading to cleaner air and healthier communities. While fusion isn't powering our homes just yet, such developments move us closer to a cleaner, more affordable energy future. With successes like the 2022 ignition breakthrough at Lawrence Livermore National Laboratory, The future of fusion energy looks promising. For those interested in exploring renewable energy options, EnergySage offers free and transparent quotes from fully vetted providers that can help you save up to $10,000 on solar panel installation. To get started, just answer a few questions about your home, and EnergySage will email you the best local options for your needs. This discovery is a notable contribution to ongoing fusion studies and brings us one step closer to a cleaner, more affordable energy future. Stay tuned for more updates on the latest innovations in energy and technology.